Yeah, I had to run next door because I called in a muffin. Did you want this one? I'm trying to call it. Next time, I get it.
All right, we'll go ahead and get started. Or I'll wait till you get plugged in, sorry. Let me get a little bit more ice, actually. Okay, now we'll go ahead and get started. Looks like we got Ted and James, and then everybody else is in class. Awesome. All right, so per Conversations Monday, I've sort of readjusted sort of the curriculum with the focus more on sort of day-to-day aspects of, I'm saying BI analyst in this case, but that's a blanket term for anybody doing analytics, data science. There's so much overlap with all those sort of different positions that for the sake of the class, that's what we're calling it here. Traditionally, and the way I was taught, which we kind of saw fail last time in terms of like sort of going foundationally through everything. And for the sake of like quickness, how quick this class goes, I think it does seem to be a lot more relevant to focus more on broad ideas and then dive into how that's accomplished with Python rather than kind of looking at the nitty gritty. So that said, today that's where we're going to start. I am sort of anticipating getting through just sort of the initial sort of like data phase, like sourcing data, pulling that into a Jupyter notebook, into Python, and doing some of the stuff we were doing last time, but really sort of like driving the why with what we want to accomplish, right? When we get data, what do we want to do with that? And how do we get it in a form where we can make it actionable, we can turn it into a visualization, yada, yada, yada. So yeah, that is where we will start today. So I've got a fair amount of just expectations for somebody that's in a BI analyst role. And it's essentially, it's everything that I've been talking about. It's a professional who's responsible for gathering, analyzing, and presenting data to help organizations make informed decisions. And that's, I mean, that's really, when we talk about data scientists and machine learning algorithms and like we scale all the way up, it all comes down to making informed decisions. Are we making the best decisions with the data that we have? And so I know last time Ted brought up, like, you can just show them the numbers and make decisions on that. But then like, oh, let's abstract a layer out and look at the trend over time. And we can make a decision on that. Oh, if there's a trend on time, can we do time series analysis and do a prediction forward? Now we're making a decision on that. And it continues to scale as we get more and more sort of nuanced within different machine learning algorithms and stuff like that. We might get to that depending upon like where interests kind of go. But for now, it's sort of like, how do we make actionable analytics with the tools that you are familiar with, SQL, Tableau, and hopefully Python by the end of this class and whatnot. My name's Tim Flanders. I am a BI analyst for Cool Guy Corporation. Every day I drive my Toyota Yaris to the building and I get out and I go up the stairs and I sit in my desk. And the first thing I do is I open up my laptop and check emails, obviously. But let's say that I've been tasked from my boss to look at what kind of sunglasses the cool guys need to be wearing, or cool people or whatever. And so I'm going to go scrape the internet for sunglasses data And so that's sort of like day in the life of Tim Flanders is he's going to go do data collection. So that sourcing data happens in many different ways. People talk about scraping or pulling it from an API, but there's an awful lot of data that can be purchased too. There are companies that's what they sell. Nate will argue that he thinks that's Gen 4 of data science is what is your data product. That's something that where I work, where Tom Flaherty, not Tim Flanders, works at Buildertrend, that's something that we definitely are looking to get into as well, is what sort of data can we sell to people and they are now making their own actionable analytics. Okay, so back to Tim Flanders. So yeah, data collection, that's what I need to do. So I'm gonna go scour the internet. I'm gonna see what's available for free. I'm going to see if I need to scrape stuff. I'm gonna see what data we can purchase. And I'm going to put together a document that I'm going to give to my boss saying like, here's what I can do for free. Here's what we can pay for to get stuff. And then it sort of comes down to what's the validity of the data, especially stuff that you're getting online. You're getting stuff online. You don't necessarily know where that's come from. We want to know the lineage. That's why big corporations will often want to pay money for data that's been validated, because then if it's not right, we paid for it and we have the contract for it, so we can point the finger at them if something's wrong. So again, that obviously it gets it a little nuanced, but for the sake of the gag, we'll continue assuming that we've got some data now. So then we're moving on to data preparation. This gets into some of the stuff that we kind of looked at last class, as far as we loaded in the Titanic data, and we started taking a look at that. And we'll probably get back into that one a little bit later too. But data prep, so that is sort of the culmination of like doing sort of data cleaning, data wrangling, like all the things that gets the data from like maybe some sort of messy form into like a nice sort of tabular. You can open it up in Excel, yada yada yada. How do we get that stuff so it's looking good? And at that point, as what I just described at a scalable level is what's called data engineering. That's what I do. That's taking this data and making it usable for everyone to an extent. Maybe it's not at the granularity they want. Like, again, maybe I'm looking at it as like every pair of sunglasses ever, but the person that wants to make an actionable data set might want to look by brand, like give me brand's average price or something like that. But the fact that the data comes to us at a very fine granularity means we can always go up, right? We can always, or I guess go down rather, depending upon how you want to look at it. You can always sort of collapse that and do summarizations and group bys to look at it at a different level. And then we can zoom out and see everything at the very, very small granular level too. Or zoom in. Yeah, I'm really messing up my verbs here. But you get the idea. Like you want to have options when it comes to this stuff. And you want it to be as detailed as possible because you can never go lower than that lowest grain of detail. So data preparation for a BI analyst can be something where they are doing everything. They are doing all that legwork. They're doing all that prep work. Or maybe you're lucky enough to work at some place where there's a data warehouse and there's a data engineer and they've already done all that stuff. And so you can just move right on to data analysis. We're obviously going to touch on some of like the dirty bits of like getting into like muddy data and cleaning it up, just because it's good to see that stuff. Like that's the power of Python too, is you can do all that stuff in Python. That's why people learn it. That's why people love it. It can do anything. But yeah, so we'll touch on that, but let's assume for right now, we've got some good data. We got it cleaned up. That's when we move on to the analysis. Analysis is sort of like, in this case, analysis is many things. Analysis is sort of like, what assumptions do we have off the bat about the data? Like if we're looking at sunglasses data, we're going to think, I'm going to hope they have like UV ratings for all the sunglasses. I'm going to hope that they're going to have like the makeup of the product. I'm going to hope they have a weight, color. Like these are all things like as an analyst that's about to do work on sunglasses data, these are the assumptions that I have about the data set. So there's different ways that we can sort of quickly glance at our data and glean that information. And we sort of did that a little bit last time, but we'll get into it more formally this time. And so yeah, we have assumptions. We need to either validate those, or if they're wrong, we need to know why and then change accordingly to sort of be able to move on. And so, yeah, analysis is not only numbers, but it is also visuals as well. I know it says data visualization is next, but for the sake of analysis, you can do some quick visualizations just to kind of, again, confirm your suspicions that the data is distributed in a certain way. Like, let's say one of the columns is price. And we look at price and we think like, oh, that's going to be in dollars, right? But we look at the distribution and it's like the average is like 10,000. And it's like, these are not $10,000 glasses. So our assumption is it was in dollars, but when we look closer, it's actually in pennies for some reason. So part of the manipulation is going to occur where we're like, well, no one else using this data is going to want to like look at it like that. So we're going to need to divide it by 10. And then now it's in dollars. So that's an example of an assumption that you have that's incorrect. You change it, you fix it. Now we're back to what we assumed that it was. So that's sort of, we catch all that stuff. We might get the intuition for that during preparation. We're going to validate that in analysis. And then when we actually move on to visualization, we can see it. But then the visualization portion actually then that's where we get some ideas about storytelling and whatnot, which then leads to our analytics and reporting. That's when we're turning this data into something that is helping someone make a decision to drive business in one way or another. Well, hopefully only one way, hopefully the good way. But yeah, so that's analytics and reporting. And then there's continuous improvement. Which is something that was not talked about at all while I was in school. When I was in school, it was very much, you're a golden god, go do data science and everyone will love you. Like, that's kind of what they told you. And then when I got, especially into the medical field, ASCOM folks, you guys probably know this as well, being in the medical field, like data's not pretty there typically. And when you build something, you need to maintain it. And if it breaks, you're on the line for it. And so when this is something like a Tableau report, continuous improvement there is relatively easy. Tableau does a pretty good job of keeping itself in-house. Something breaks, you might get an email and then it's, I don't know, it could be something in your data flows off or your extract failed or something like that. But when you get to the point where you are building, let's say you're building custom dashboards with Python, there are ways to do continuous improvement. So that's not a big task that you have to do daily, but it's something that you need to keep in your mind as you're building that stuff out. Again, as a business analyst, you're sort of a jack of all trades of all these things. So you're maybe not making something that is scalable to like 1,000 to 10,000 people are going to be looking at it a day. Maybe this is a dashboard that only a few people are looking at, but they're C-suite people, so it's important to keep that going. When you do get to the point where we need continuous improvement at like scale, that's when we get into those enterprise solutions I talked about last time. That's when we get into Data IQ, we get into Databricks, we get into Azure, all that stuff. So yeah, for the sake of this class, we're cognizant of all of the big things, but I mean, for what we're trying to do, assume that we're not 1,000, 10,000 people aren't going to be looking at what you're making. And if you do get to that point in your professional career, you will have the tools to do that properly. Just because if somebody's asking you to do that, they better be giving you the things you need to do that stuff. Okay, so yeah, that's what's on the plate for Tim Flanders, working at Cool Guy Sunglasses for the day. It's a lot of stuff, but we're gonna get through maybe like the first 2 steps of those, hopefully in this class, and then we'll continue to sort of work our way through that sort of workflow. Right, so I get in the office, I sit down, I've got coffee. I got emails checked. I'm making a mess. So yeah, I'm going to sit down on my computer. I would say Buildertrend is the first company that I have worked for where they gave me a Mac. Every other place I requested a Mac and they were like, "No, we don't want to." And I was like, whatever. But so you might not, you're going to typically take what you can get if work's giving you a computer. I've worked primarily on PCs, which is terrible, but it is what it is. Sorry, PC people. It's fine. They're good for video games. I know that much. This is terrible for video games. And they're good for data science too. So yeah, we're going to sit down to my laptop. I've got a Dell because that's what they gave me. And yeah, I'm going to open up my Python environment. Typically, at the level of analysis we're doing, I would say that you're very likely going to use Jupyter Notebooks exactly like we're using in class right now to do a lot of your stuff. So this is totally applicable to everything else. And the notebook style of coding like transcends into Dataiku, Databricks, everything. Like it is there's nothing crazy about that. Like it's very, very traditional and it is very much like kind of the standard. I think when you get into like more programming engineering, you might use .py files and those things are going to actually be deployed. But think of those more as like an actual application or an exe that you're launching versus something that is like more of a worksheet where we're working through code line by line and we're getting output. So yeah, Tim Flanders does all of his stuff in Jupyter Notebooks. And I use pandas, I use NumPy. Scikit-learn or sklearn is sort of the premier data science modeling library that Python users use. It is single machine though, so it doesn't scale very well, but that's fine for what we're doing here. Matplotlib is good for visualizations. Seaborn is super sick for visualizations. I actually think that's a little more superior. ggplot2 is not on there. I didn't add it because it's more of an R package, but there is a Python backend. Plotly is another visualization one that we're definitely going to get into. Yeah, so I pull up my Jupyter Notebook, and I can get going. If I am putting together some sort of an application that is going to be like deployed and it's going to be like a .py file, I might use that in an integrated development environment, which is an IDE. We talked about this too. That is PyCharm. Visual Studio Code is the one I use at Buildertrend. There are other ones for multiple different languages. And that's sort of like Jupyter Notebooks are sort of like a very slimline version of what like a bigger IDE would be. But in my opinion, what's great about Jupyter Notebooks is the simplicity, or like similar to my bicycle. I have one gear because of the simplicity of it. Now nothing else can break. I've just got, yeah. So yeah, I might open up Visual Studio Code. I do some SQL work in Visual Studio Code because they have some good stuff in there. So Tim Flanders might do some of that. You never know. Data storage, like if I'm getting this data, do we have a repository for it? Do we have a Microsoft SQL Server? Do we have Postgres? Or is it NoSQL, MongoDB, or something like that? Or are we just using cloud storage? Are we using Dropbox? Like that's fine. Like any data storage solution is fine, depending upon what the assumptions are on your role. Maybe it's a SharePoint. People still use. I mean, at Cool Guy Sunglasses, a lot of people use SharePoint for stuff. It's nuts. But then also, like, as far as files go, like, is it an Excel file? Is it a JSON file? Is it a CSV or something like that? So those are all things, and especially as I am getting data and I am trying to figure out which ones we want to use. If it's JSON, I might have to go in and do a little bit of work on that to get it so it like fits into, let's say we have Microsoft SQL Server. There might be some massaging there. Right, so then data processing. This kind of goes back to some of the stuff where we were talking about data preparation, data analysis. That falls under data processing. That's where we're using either SQL or Pandas or something like that to transform our data, filter it, converting pennies to dollars if that's occurring again for some reason. That's data processing. I do a lot. Tim Flanders does a lot of that. Data visualization, obviously, we talked about. There's Seaborn, Plotly, all the big ones. And then potentially, let's say we're making a data set and all we've done is just turn it into something that is clean. And then somebody else, maybe a non-technical person that is technical enough to use Tableau or Power BI, now they have a very clean data set and they can do analysis of their own. And you've allowed them to do that. Your knowledge of Python has allowed them to do that. And then obviously there's some other analysts I work with and we do collaborations. Jupyter Hub is exactly what it sounds like. It's where notebooks you can come together, similar to GitHub where like people are working on different ones and we're merging them and doing that stuff. And then deployment goes back to continuous improvement. Once these things are live, are we watching them? Are they getting updated with new data? If you're building a model that is doing some sort of prediction, are we looking at, is that prediction still accurate? So let's go back to the sunglasses trend where we're looking at sunglass use over time. And we can see, obviously, sunglasses use goes way up in the summer and it kind of dips down in the fall. But then like in the winter, there's spikes in weird places because it snows and it's super bright. So people need sunglasses. Like, let's analyze those. And like, we would assume we're going to see some spikes in winter. And if our model is suddenly no longer predicting those spikes, it's like, okay, we need to go back to that model and retrain. That's part of deployment. That's part of continuous improvement. Okay, cool. Where are we at here? Oh boy, I'm barely 15 minutes in. Cool. Well, let's stop for just a second and just like check brains. Am I going too fast? Is this all making sense? Is this hitting below the belt, above the belt? Does this seem okay? Folks online too, please feel free to chime in. My volume is up.
Makes sense.
Cool. And I can also just assume no news is good news too. Okay. Cool. So we've gone over, again, to sort of reflect here. We've gone over sort of, the BI analyst role is sort of what we're looking at. We've gone through a summary of the day in the life of Tim Flanders, business analyst for Cool Guy Sunglasses. There's a lot to do there, and there's a lot riding on his back. And so we have a lot of different resources when it comes to learning and doing research and development and troubleshooting. I can tell you that I still use Stack Overflow quite a bit. Are you guys familiar with Stack Overflow? It would be your best friend. Pretty much, yeah. So let's say, let's go to Stack Overflow and start looking for stuff. So feel free to follow along too. Actually, I'm gonna get some bragging rights here real quick. Oh no, get out of here. I'm not gonna authenticate right now. I'm in the middle of something. Let's do my old, still has my old Nebraska Medicine or Nebraska Methodist. So Stack Overflow is this. It's just a place to go to ask questions. It can be very daunting to ask questions, and I've seen some people get ripped apart on here for asking questions where they haven't used the search bar. Pretty much anything Python related has been asked on here before. So I would not go in here like guns blazing. I want to know how to use pandas. It's like, just like go find a tutorial or something. I don't know, like, or be in this class, more like it. But yeah, so let's say Tim Flanders got this data set and he's looking at sunglasses. Again, we're looking over time. And I've realized that I want to look daily, but I want to look daily at in my time zone, and the time zone stamp on the data set is like Pacific. And I'm like, well, I want to convert that to Central Time. Well, how do you convert a timestamp in a data set? I don't know. Let's figure it out. Let's look. Python convert timestamp to CST. Here we go. Converting Unix timestamp to local, which is essentially what we're trying to do. And so this is actually a pretty good version of a question. When you do ask stuff on Stack Overflow, you want to try and give them as much knowledge as possible, and definitely show, here's the things that I've tried that are failing for me. If you can show people what's not working, then they have a place to start, and they can reverse engineer it and they can figure it out. So in this case, he's trying to subtract, it looks like 6 hours. So the first 60 is going to be seconds, maybe milliseconds. I forget what Unix timestamps does. But here, this guy essentially says, with newer versions of Python, we're using like 3.9, so we're good. You don't have to do it manually. Like, this person is attempting to do this conversion manually. They're attempting to subtract the amount of seconds from a timestamp to change it to their local time. And this guy essentially says, don't do that. You can import this. You can take that, and I know it's weird to do date time twice, but that's just how it works with the aliasing. And if you use now, this now is going to look, it's going to use your terminal, and it's going to look to see what time it is on your computer. And it's going to take that in, and it's going to apply that to the timestamp that is within the data. And so it's going to convert all that for you. And so this is why Stack Overflow is great. Again, I've answered some questions on here. Got 1,378 points. I got bored at my medical jobs, and so I would just come on here and answer questions. So yeah, but this is totally cool, right? We like this. We like that there's like a place on the internet that I can go. And then another thing would be ChatGPT. Are you guys familiar? Has anybody in here used ChatGPT yet? So like, you can, let's do it. Should have put this in our thing. I don't know why I didn't. ChatGPT. Let's sign up. No, let's do I have one with my Pillartrain account? Oh, it'll use it. Use strong password. Now you guys know my password. Oh, I don't know if it's going to work. I'm using a new browser today. What's that? It's recorded. Yeah, I'm not terribly worried. Okay. I'll have Nate check it out. And this is a throwaway email address too. Let me authenticate this real quick. I'm not interested. Which one is this? Oh. Okay, that's not working. Sorry. No, not. There we go. Cool. First name Tim, last name Flanders. Let's stick with the bit. Birthday. Oh, I was born in 2985. Wow. Oh, you need a phone number too? What's my Google number? Now this is even worse. I'm going to open up my messages in front of everyone. Here, I'll do it down here. I promise this will be cool. Oh no, this thing keeps glitching out. That didn't come through, of course. So if you guys haven't, you can follow along too if you guys want to sign up for this. Yeah. If you just go to, just Google ChatGPT. Oh, they got my virtual number. Yep. Dang it, it's giving my already linked account, which has Builder Trend stuff, which I probably shouldn't be showing. Maybe I'll just try and see if I can hide that stuff. Put this over here real quick. I'll just do this. Well, so you can literally ask it to do code for you. And it's a really good way to troubleshoot your code too.
So I'm in here, I just do the chat.
Yep, and just ask it a question. Say, how do I import data into a Python notebook with pandas? And you can even say, give me example code. Yeah. Pandas. But it'll probably catch that.
Oh my gosh.
Yeah.
It's literally giving you instructions and the visual.
Yeah.
This is amazing. My cousin uses it a lot.
Yeah.
He does he said he does it to make his SQL skeleton code, and then he types in what he needs.
Right.
My other cousin who's graduating in Texas, he said they banned it if you're on campus, campus Wi-Fi, you can't access it.
Really?
Yeah.
Wow. We're using it right now. We're using it at Builder Trend right now to try out dummy code to try and break stuff. What you don't want to do with ChatGPT is put in actual things so I can't remember who the company is. You could probably Google this if you wanted to. But there is a company where they were putting their information, they were putting budgeted information. It was maybe it was Tesla. I'm not sure. I-
Analyst just make like
Yeah.
skeleton where you take that and type in what you need.
Right. And so there's a lot of the stuff, like when I'll come up with sort of like basic ideas for different data flows that I want to do at work. And I will really haphazardly throw together code, and I'll say, go through this and make it work. And then it gives me something that I have now prototyped that normally would have taken me an hour and a half. Now I have something that, like, again, all I'm doing, it's the same thing that we're talking about here. I'm checking my assumptions. I want to do something. I want it to work this way. I'm assuming it's going to work this way. Now let's prototype it and see if we can get it to work. So all of the mindset with this is all like usable, transferable to other positions, like pretty much anywhere. And it's about problem solving and whatnot. And if ChatGPT solves problems, you can do that too. And so, like, I guess to pause again real quick, I haven't figured out exactly what it's going to be, but Nate wants me to do projects in this class. And so that's why I was asking some of you guys about data that you're familiar with, data that you've worked with in the last couple classes, because I figure you already have a lot of those assumptions figured out in terms of like building stuff. So I was thinking that we could use that for stuff. And so we still might, but ChatGPT is not, you can use that on there. Like, yeah, they're banning it from colleges, but I work for a huge company and I use it all the time. So like, oh yeah, so it's just banned on the college Wi-Fi.
Yeah.
I got it. Well, they're banning TikTok in Montana, so see how those hotspots go. But yeah, and I meant to add that here. It drives me nuts that I can't edit this. I was editing it literally right before class, and now maybe it's because people are looking at it. I don't know. Let's see if I can duplicate, copy, link, add to favorites. You guys are gonna probably find typos in here, and I can't change them. But anywho, I should put this at the top of the list, really. And if so the caveat with ChatGPT is that it's not actually like as crazy as a lot of people say. People are like, oh, it's going to take over my job. It's going to do this. It's like, no, it's like, sometimes it's wrong. Some like doctoral people were talking about how they asked it some references and it made up papers by made up doctors. They couldn't find any of it. So take this stuff with a grain of salt. I don't know how big the grain is, but think about it, even the code itself, it's trying to do the best it can with the data that you're giving it, with the prompt that you're giving it. But it is always a very good place to start out, because sometimes just starting to code something is the most daunting part. I've got a blank notebook and I need to start from scratch putting together stuff. Go to ChatGPT. Let that be your starting point. Then you've got something to work with, and then your brain gets going, and you say, "Oh, I can do this, and I can do that," and that's the end goal.
So what's the best way to use it without compromising data?
Just don't use finance data from your finance department. Don't be an idiot. Don't put your social security number on there. Don't yeah. And I'm not putting any super crazy Builder Trend stuff in there. If this is on YouTube, I don't want somebody from Builder Trend later being like, huh, look at that. He's broadcasting this to the world. So it's just for my personal safety. Obviously I have read the paper or the news about people putting in stuff there, so I'm not doing that. But yeah, just trying to keep stuff that I'm working on somewhat proprietary. So that's the only reason I'm not bringing that up. But yeah, as far as I don't know, there is a bigger conversation around all of the data that you're putting into ChatGPT is more training for it. So you're literally feeding it. So morally and ethically, are you okay with that? Are you okay with But I mean, that goes with everything in your daily life. If you use social media or if you use Google Maps or anything, Apple tracks your phones and everything, they know where you are. So you're leaving a data footprint constantly. But of the ones you can be cognizant of, like for me, my mother hates this, but I don't post a ton of pictures of my kid on social media because I don't want to feed the algorithm with her likeness and whatnot. Am I crazy? Sure. But like also I work in data enough and I've seen obviously large language learning models like ChatGPT. There's only a matter of time. I mean, Stable Diffusion exists and that's doing stuff with imagery. And there's like a lot of that is trained off of a website called DeviantArt. And so people that have done art for years, putting it on there, it's now stealing their style and doing stuff in that particular style. So there's morality and ethics behind some of that stuff. So that's up for you. That's up for you to decide, obviously. I think OpenAI, I think that they're a decent company. I think that they're trying to do the right thing with what they call artificial general intelligence, AGI. So I'm fine with putting that stuff in there. It's no different than Google searches. You're just being a little bit more with ChatGPT. You want your prompt to be kind of as detailed as possible, which is weird because it's the opposite of Google, right? With Google, the more detailed you get, they're like, there's not an article in the world that matches this crazy thing that you're asking about. With ChatGPT, it's like, oh, really? You want to talk about this? Like, let's go. He'll whatever it is, we'll talk to you about it. Okay, enough about that. GitHub is another great solution. I think that ChatGPT is trained off of public GitHub data also. I think that's why it's good at coding. So we can go to GitHub and I want to just, here, I'll sign in and we can take a look at some of my stuff and I'll authenticate. Things I do for authentication. Cool. So let's say, oh yeah, so this is big. So let's go back to GPT for a second. And this is a little tangent, but it's still, I think, applicable. So with the website on OpenAI that I asked you guys to go to, if you didn't go there, don't worry about it. I was sort of talking about how you are feeding that algorithm when you ask questions. And especially if you like the answer, they know they've done a good job. That's another data point for the model to train on. And then it just gets more accurate and, potentially sentient and going to take over. I'm just kidding. But if you don't want that, this is GPT for all. This is MIT licensed, meaning that anyone can run it anywhere, even like corporations don't need special licenses. And you can put together your own large language learning model. And so then, and this is something that Tim Flanders, I'm trying to convince the uppers to do, is like, let's get our own, whether it's on cloud or on-prem, let's get our own natural language learning model and let's have all the employees use it. And now they can ask those finance questions and we can keep all that stuff in-house. And that's sort of what this is. And so if you look, this is pretty much the same. If you guys went to ChatGPT, it operates essentially the same, the GUI does. So yeah, and this is on GitHub. And you can literally go in and look at all the source code if you really want to. I don't know why it doesn't. It's probably disgusting. Ew, JSON. But anywho, so that's on GitHub. Let's see what else is on GitHub. Oh yeah, so this is actually where I was pulling some of the data that we're going to be looking at later today. This is a package that every week on Tuesday, they just post a data set and you just go to town doing visualizations and fun. This is like, if you guys want to do projects and stuff from this, there's literally 6 years of data. So 6 times 52 is like what, 312, something like that. Yeah, and this is all this data is on GitHub. So here's literally the CSV. And so, yeah, Tidy Tuesday is R for data science. Again, R is just another statistical language. Once you get the syntax of Python, you can probably look at R and understand what's going on there too. And so, but yeah, let's real briefly. So I'm Tim Flanders. Let's see if they have sunglasses on here. They might have sunglasses. The only thing that I'm bummed out about with some of the stuff on GitHub is that it can be hard to search. And maybe I am an idiot and missing something completely. So folks online too, if you're better at GitHub than I am, I unfortunately use it professionally and I can't answer this question. Yeah, here's a chocolate data set for anybody that likes chocolates. Who would like that? Just kidding, I love chocolate. So this is actually sick. And so this is, I want to go point at it, but then you guys can't see me on here. This is sort of some of the stuff that we're trying to do, right? This is the data set. These are all the columns within the data set. And these are the different types they are. Integer, so that's going to be a number. Character, if we were looking at in Python, that might say object, but it would say integer for some of the other ones. Double is a numeric thing, but then it says exactly what it is. So that last one is the rating. So we have a rating between 1 through 5. So this could be hella cool to model, really. Like, given the country of origin and where the manufacturer, is there a way we could build like a linear regression that could predict the rating of the chocolate? Probably, honestly, that's a pretty fun data set. And that's on GitHub. Again, there's just massive amounts of stuff on here. So let's say we want to look up, let's say we want to get like way into polars. So we talk about pandas. We're going to be mostly working in pandas. Polars is another library that does similar stuff. So I want to do analysis with polars. And there's absolutely nothing. All GitHub. There we go. So this is almost like a Google but this is like actually completed stuff. Well, for the most part. And again, I would sort of take this with the grain of salt that you're taking with ChatGPT. Is you didn't code this, so there could be mistakes. Maybe a good idea is to to check your assumptions on the code is to maybe copy this out and give it to ChatGPT and say, hey, debug this for me. Tell me if there's anything wrong. That's not a bad idea. Yeah, so here we go. Here is a Jupyter notebook, I think. Wait, Jupyter notebook, yeah. Oh, this is a Udemy class. Can you just download this? This is things people pay for also. Yeah, here we go. Woo! So this looks familiar, right? This is Jupyter. This is everything we've been doing so far. This is like a PDF version, sort of. It's like GitHub will present this in such a way that you can read it, but we can't run any of this code within GitHub right now. But if we downloaded it, we could. Opening GitHub Dev, opening desktop. Yeah, so we can, if we wanted to, we could clone this repository, and then we have all these notebooks. Maybe we'll do that I'll probably actually do that in next class. I'll have everybody learn how to clone a repository like this. So when you do see something you want, you're able to pull it down and it runs properly. And again, this is a Udemy course. Are you guys familiar with Udemy at all? Yeah, I mean, it's another online video tutorial stuff that costs money.
Sometimes they do have like some free courses.
I've done, yeah. When they do free ones, sometimes I just like turn it on at work in the background, like a podcast or something. Just like,
Well, they'll have like really cheap ones, like $2.
yeah. I mean, this is cheap too. It's free. I mean, granted, you don't have anybody walking you through this, but this looks fairly documented. Like, it's telling you what's going on. It's giving you references. Look what actually, this is hilarious. Look what data they're using. They're using the Titanic data. So that's another common theme that you'll see when you're going through any sort of tutorial, be it on GitHub or any other class. Udemy. I mean, Udemy is using the same stuff that we're using. So like, that's just, it's typical. Yeah, I mean, this could be fun. I mean, this is potentially a project too. If you guys want to do something like that, is like the stuff that we're doing right now in Pandas, recreate that in Polars or another package, and then just talk about the differences and talk about maybe you have a preference over one or the other for whatever reason. That's the type of stuff that like I want to push for, because that's when your brain stops thinking like this is calculus and more of I get what's going on, and now I have opinions on things that I like when it comes to programming and stuff like that. Yeah. So, okay. So GitHub is totally cool, totally great, totally tons of stuff. Again, if it's made by just a person, you don't know that person. They might be a bad coder. In this case, this is a Udemy course, so I would pretty much trust this. But that's just me. All right, let's go back. Cool. So when we were doing some of the stuff on Monday, I kind of really quickly mentioned packages or libraries. And Brenda, I think you were like, what is that? And I was like, ding, 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 ding. Got to talk about that. Let's talk about that. That's when we're importing things in. You can just like, we were importing NumPy, and you can import NumPy and it'll import everything. And then you have to call it. You have to call NumPy dot whatever you're using, or you can alias it, import NumPy as NP. Then we're using NP dot to grab that stuff. You can also import particular things from packages if you don't want to get the whole shebang. We'll get to that later, but where do all these things come from? Like where do you just import just like pull from like a series of tubes or whatever? A lot of it comes, PyPy is the big repository, and PyPy stands for Python Package Index. This was recently scrutinized because I'm trying to remember there was something happening with a particular package, and like it went unnoticed, and it was like detrimental to like some of the dependencies for other packages, I think. But they have since, I believe, figured a lot of that stuff out. But yeah, okay. So here it is. What's so cool about it? Pandas. That's what like the number one data manipulation thing we're going to work with. We can see that there's quite a lot of pandas here. Pandas RS, pandas. We're just using the regular one, just regular pandas, not pandas 2. And you can look at the date, 2017. We don't need that. April 3rd. Sheesh. That was like 2 weeks ago. That's the one we want. Cool. Yeah. So here it is. We can see the version. And so, yeah, these little guys are cool because you kind of get an idea of how often it's being used and where it's being maintained. So we can see it's on PyPy, but we can also see it's on Anaconda. That's our cloud. That's what we're doing, everything on Anaconda Cloud right now. So when we pull pandas, we're pulling 2.0, we're pulling the newest one, which is really cool. Some of this stuff, I don't know what it means. Status stable, I'm sure is good. You can see the amount of downloads. Yeah, bless you. 110 million downloads per month. Can you like fathom that? That's how much this package is used. Like, I didn't even know 110 million people coded Python. Like that's like a third of the U.S., right? Something like that. I don't know. That's insane to me. So yeah, that. Pandas is it's more of like the tools to manipulate data. Like and it is also how you read data. It's a way to ingest data in. And it's a way, so similar to how like in SQL you were, yeah. A lot of people prefer this to SQL. And again, with 110 million downloads, obviously this is insanely popular. And it's very good for single machine use. Everything Tim Flanders is doing, this is good. Everything you guys are doing, it's good. As it scales, that's where we sort of run into some back-end issues as far as like how long things take. And that comes with everything that you're doing. When things scale, the things that you learn on a smaller machine tend to not do as well. Yeah, I think we're at a good pause with talking about this. So yeah, we will pause. We'll do 10, 15 minutes, stretch your legs, go to the bathroom, folks online. You've probably been doing that the whole time. Good on you. Yeah, so we'll break here. When we come back, we will talk a little bit more about PyPy. We'll get into documentation and keep on rolling down the Tim Flanders BI roll. Heck, cool guy sunglasses.
Is that a real person?
No, I made it up. Oh no, my name's Tom Flaherty, so I was like, what's close to Tom Flaherty, but not Tim Flanders? Okay, I'm gonna do the banner again. Oh man, this is really.
I'm supposed to remind you to snap.
To what?
To snap and to say you're gonna do something.
Yes. What time is it? Yeah, you're 100% right.
Are you fasting?
I do intermittent fast, but I stopped eating at around 8. And last time you were here, I had lunch and then I taught this class, and I was just like, I can't eat now. What?
I'm good.
It messes with me, like talking at that point. I've been doing it so long now.
Did you know it takes 4 hours for you to digest your food? 4 hours? Yeah, so that's why you're not supposed to like eat and go to sleep, because your body doesn't digest while you're sleeping. It can't. It's a very slow process. That's what they say intermittent fasting is really good, because like if you clock your digest, like I sit and eat, so then like say you last meal at 5:30, 4 hours in there, but you probably don't super on like snacks, but then provide your stomach to like actually let the body rest, not try to digest that. So.
Yeah.
The random things I know.
Yeah. For me, it's just like trying to like stop eating, because I would like snack or like, I don't know, have a drink or something before bed, and that's just absolutely terrible for you too. You get bad sleep, and so now that I have a kid, I need to get good sleep. Whoop, what have I done? Oh, Lord. There we go. Oh, my.
And spilled and espresso. Do you religiously practice your fasting?
Yeah, I'm pretty good with it. For the longest time, I was doing like 3 o'clock to like 10 o'clock, but that was like messing with my sleep. Because like I would like be like, oh, it's 10 o'clock, I can still eat something, or like I have a drink or something, and then it's like 10:30 or 11 rolls around. It's like I should go to bed, and then I would just sit in bed like wired or something. Like it was just weird, yeah. So I like moved it.
I don't have that effect.
What's that?
So I don't have that fact. Like I can drink coffee and then like, okay, I'm good to go to sleep like the next 10 minutes.
I used to be like that, but now I don't know if it's kid changed me or getting older changed me.
Nothing. Anything, I'm more. It's just,
Like I can say, I think my brain can, like as soon as I hear someone like, I'm like, oh, I'm up. Like, but I could have slept fine without it. Like I'm pretty good, I guess, what do you call those little people that wake up for the most random things? So my husband's like a heavy sleeper where he just snores the horror. But yeah, but coffee usually, my husband's like, oh, drink coffee. I'm like, yeah, well, like in our culture, it's very like a thing for after you're eating.
Mm-hmm.
So like right now that I ate, like, in other words, I inhaled that very well. But I was like, okay, I need coffee now.
Got
That's
yeah.
just so used to it.
I mean, I'll do coffee here since it is here. Normally, I don't think I would. So I downed like half that thing on Monday, and I went home and I got to bed at 11:30 and fell asleep pretty quick. So, yeah, I don't know. I think it just depends. Maybe their coffee's not that caffeinated either. I don't know.
I mean, I think it's coffee.
How old do you think this ice is? I brought ice from home when I saw this and I was like, no. So, some more thoughts about ChatGPT. When people talk about it like taking over their jobs, I always reference that when the printing press came out in like the 1500s, people thought that it was going to make the world lazy and that people wouldn't talk to each other anymore. Like it was similar thoughts to ChatGPT were being said about the printing press, like what essentially moved us into a more modern age. So while ChatGPT is much different in terms of like what it's offering, it's still, I'm curious if we'll look back on this in however many years and be like, remember how we thought that was going to be bad? Life's great now, but hopefully I'm right. I could be wrong. I'm going to double fist and use Diet Coke and coffee. Now, need fuel for the rain-soaked ride home, which isn't it? Weren't they saying? Well, they think right anytime. Oh, okay. There's a few things over there. Yeah.
until like 11,
Oh, they didn't be till 11 o'clock, right?
Yeah.
Yeah.
So it's supposed to start raining at 8 and lightning.
Okay. If there is a tornado, Nate said that this back here is a tornado spot. So if people come and say we got to do that, I guess we got to do that. Okay, we'll go a couple more minutes here. I'm gonna try and Did you guys hear the lightning last night?
Yeah.
That was terrifying.
Honestly.
I was gonna say my daughter passed out through all of it.
I know, it's like,
That was fine.
this happened like this, like,
Oh, there we go. Cool, I got my stuff saved and cleared, so I can show a little. If you guys didn't download ChatGPT, I will pull it up here real quick. Actually, I think with this browser, I can go over here. Cool. All right. Now I won't get in trouble. Yeah, so we would. This is not exactly 10 minutes, but if you guys are cool to get going, I'll get going. Cool. Yeah. So we'll get back to pandas in a minute. I do want to show a little bit of ChatGPT. Let's do. How do I install Python 3.95 on a Mac computer? So it might be fun if you guys are into it, I guess. I know there were issues with SQL on people's computers. I bet we could ask ChatGPT how to install Python on your computers, and we could probably do it that way. That could be fun. How do you do it at the command line? Yeah, so here we go. So let's take a look at what ChatGPT got wrong here. So this is a really good use case, I guess. So we talked about command line stuff, and I said a lot of the stuff that you guys will be doing, there will likely be very minimal need for you guys to do anything at the command line. But I asked ChatGPT, how would you install Python at the command line on a Mac 395? And so he gives us this nice bin bash. So this is essentially saying, go to this website, raw GitHub user content, homebrew install, this stuff. So this is installing homebrew on your computer, and then homebrew is then a app or a program that has access to a lot of different versions of different programs. So it'll install different Python versions and stuff if you need that. So that's the first thing it's doing. And this is a bash command, which it says right there. It says bash. And then you do brew update is also a bash command. But what does this say that it is? It says that it's SQL. So it got that wrong. So let's keep going. Brew install Python 3.9. It says it's CSS, which is cascading style sheets, which is like a web programming language. Then you check your version. Again, it says it's CSS. These are all still bash commands. So again, ChatGPT is fallible. It is not infallible. Okay, anywho, let's get back to PyPy. Cool, yeah. So again, we're talking about resources. You're on the job. Tim Flanders doesn't know everything. Like, he's got to go figure some stuff out sometimes, especially this world is always changing. I talk a lot about the things that I learned when I was in school and how a lot of that stuff is kind of thrown out the door now. I made the comparison of like driving manual versus automatic. how like purists will be like, oh, you need to drive stick, and then you feel how the car really feels, and you're not really driving if you do that. And it's like, well, no, I mean, if I'm just trying to get from point A to point B, an automatic's going to be just fine. It's the same with data science tools. Like, yeah, you can do it the old school way and yada, yada, yada. But for me, Tim Flanders, my boss, just needs to know what color sunglasses are going to be in style next season. And I don't need to go through the rigor of all of the stuff that comes with traditional statistics and data science. Like, yes, they're very important, but somebody has already done those and put them into a package that someone like me can use to make informed decision making, or at least give that to whoever the business stakeholder is that needs to make this decision. So we are looking at pandas. Tim Flanders needs to get in here and needs to learn how to do some merging and joining of data sets. We remember in SQL, left join, outer join, inner join, aliasing, stuff like that. Pandas can do that too. I can click this link and it's literally going to take me to the Pandas API doc, or all their documentation. And there you go. They use, assuming you've imported Panda as PD, the same way, remember how we aliased NumPy, we would call np dot whatever it is. Same with pandas. We're going to, in this case, they aliased that as PD. That's like almost universally done. I would say it's probably, you could probably make a joke about importing pandas as something else, I guess. Bless you. But yeah, so PD is what you're normally going to see. And so now when we do a PD merge, we can see all the different things. So we have what's on the left, what's on the right, how we're joining. It defaults to inner, which is interesting. I don't know, inner's fine. Then you have on. Remember, with SQL, we were doing that same thing. We were saying join X to Y on X ID equals Y ID, and that's how everything was being joined together. It's the same thing with pandas. So just having a little bit of that understanding with SQL is applicable here because you've seen it before. And so you're like, oh, this is the stuff that I've done in SQL. It's just a different way of doing it. It's just a different syntax. And that's what syntax essentially is getting at. And so, yeah, all the documentation is here. This is so helpful. Me, Tim, I love this. Now I know how to do all the merges that I need to do. And there's examples, there's visuals. I really like, I know I always talk about tabular data, Excel, blah, blah, blah. This is the type of stuff that I'm talking about. And when they have visuals like this and you can see when they're joining things to one another and you see the sort of desired outcome or the actual outcome, that's like totally helpful for me because I'm a visual person. So like when I can actually visually see these things merging in my head and then an actual picture of it, I love that. The Pandas documentation is like top notch. So yeah, huge tool. Again, you're getting with every sort of thing that we've looked at right now, we've went from like broad questions and we're kind of whittling it down to like, how do I do something versus what's the best way to do something? And now it's sort of like, I need to know this exact thing about this exact library. So I'm going to go to the documentation and I'm going to go in here and figure out duplicate labels. Like we're getting more and more granular. Yeah, so that is, again, we're installing, a lot of our installs come from PyPy, but it's just an amazing repository of lots of documentation. If you need it, it's there. It's not like you should be going here all the time. I mean, it's cool if you do go here all the time too. Whoops. Back to here. Cool, yeah, now we were looking at Jupyter Notebooks on GitHub, and we found a Udemy course, which is crazy. Here is the Jupyter Notebook gallery. I think this site used to be a lot cooler. Right now, it's like really minimal, and it's just like 10 things. But it's like the way that it talks about itself is like it's amazing. So I don't know if I'm missing something here. I used to come here all the time. But all of these are very good. Linear regression is huge. That's like in terms of like statistics and just like the most simple, but one of the best models that there is a regression model. And that's basically where, remember when we were talking about chocolate and we had a rating. if we were trying to use all of the data that we have to see if, given the amount of sugar and where it's produced and the time of year it's produced, can we create a formula that will predict the rating? That's what a linear regression would be able to do. Yeah, and this has exercises. Holy moly, yeah. So this thing is huge. Woo! But yeah, this is just more stuff to come and look at. But me, Tim Flanders, I know how to do linear regression. I'm getting out of here. So that is the notebook gallery. Again, I am unsure if that's being updated anymore. This is the one that I like. This goes back to GitHub, but this is a curated compendium of tons and tons of Jupyter notebooks. Let's see here. When was the last time he updated this? January 9th. So this year. So that's cool. That's another thing that you want to look at when you are on GitHub. Look at the last time it was updated. Has this not been touched since 2016? It's probably garbage. Has it been updated yesterday? Oh, maybe it's being updated too much and it's like unstable. So like that's good stuff to like have in the back of your head when you're looking at this stuff. So yeah, this is being updated. So here we go. Statistics, machine learning, and data science. Here is a smorgasbord of stuff. I mean, you guys think calculus is boring, Bayesian statistics. Whew. It's cool, but it's boring. Big data for beginners. That's cool. MapReduce, Spark. So yeah, this gets to what I love. Spark. Tim Flanders would love Spark, so he might bookmark this for later. Yeah, there's lots of cool stuff in here. So again, we're just looking at resources. We're understanding that there's a breadth of knowledge. Every time we learn a little bit more about Python, some of these things will make sense, and we're going to say, oh, I want to go back to that, and I'm just going to take this code and I'm going to use it in whatever I'm working on, and that's totally cool. You should take all this stuff. You should and try and use it. And if it doesn't work, try and figure out why it doesn't work. Like that's also very important for learning this stuff. And so then I think that's most of our. Yeah, and then library documentation, which we did in PyPy, where we get into the pandas documentation and stuff like that. We can do that with pretty much any package that is on there that links to a documentation. Like you can absolutely do that. So let's reflect here real quick. I've gone through my setup, what I do when I get into work. I've talked about like I'm doing stuff in using Python, and I'm using pandas, and I'm doing things in a Jupyter notebook. Right now, I'm just using CSVs because that's all I have. And so I went and looked online because I was trying to figure out, is there a good way to do sunglasses analysis? So I hit up Stack Overflow, but that was no one's talking about sunglasses on Stack Overflow, so that wasn't right. I did look at GitHub. I found a few Jupyter notebooks that are interesting. They mentioned a couple of these packages, so I went to PyPy and looked at documentation. I went to the Jupyter Notebook Gallery and didn't understand why there were only 10 notebooks, so I skipped that one. And then I went to the big Jupyter one we just got done with, and I found some stuff there. So Tim Flanders has some stuff now that I can kind of pull some examples from to start coding. Yeah, and so now we're going to get into EDA. And I call this initial EDA because EDA is exploratory data analysis. That's sort of like some of the stuff we did last time. We were understanding like we noticed that there was one missing person, or there was a person on the Titanic that didn't have like a price associated with their ticket, and we assumed it was a stowaway, or maybe it was Jack, but then we remembered Jack had a ticket. That's EDA, that's exploratory data analysis. That's what we think we know about the data. We're now validating, like if it's pennies or dollars, stuff like that. And so we're going to do a little bit of that here in this document, and then we are going to get back into the Titanic notebook. So first, I have a data set in here. I really wish that this was as interactive as it says it is. Like I want to run this, but it won't let me run it. Why? Why you say no run? That's bizarre. Okay. Oh, I guess it is running. It's got the output. Okay, cool, good enough. So this is the data that I had in the last class that I just briefly showed. And I thought it was Nobel laureates. It turns out it's just the US government collects data on all doctoral degrees, graduates every year. So how many new doctors do we got that are gonna be a pain to work with? So we've got a CSV. So we're gonna load it. Again, we're gonna import pandas SPD as we do. And I'm gonna hit PD dot, and I'm gonna start writing, but you could start writing anything. Typically within Jupyter Notebooks, it'll do autocompletes for you for all the different things, all the different functions or classes that are within that. And so there's one called read CSV. So I'm going to read our PhD CSV, and I'm going to, again, we're using the equal sign to define an object, a data frame in this case, as df. So we have loaded the data set into our notebook. And then remember last time we talked about what is the shape of the data. So essentially, what type of a rectangle is it? Is one way you could look at it. To me, it's like how many columns and how many rows. And so that's what we're running here, df dot, and then you can see all the things that are sort of all the metadata that Pandas has put onto this data set. That's what shape is calling. That's like the extra data that it also, because it does its own quick analysis when you load it in there, and then you can use that to sort of do your own EDA, which we're doing right now. So here, the first one is rows, 3,000 set. Oh, this isn't the Titanic set. So we have I can't remember what year this was. There were 3,000 doctors, or I don't know. Actually, I guess I've made some wrong assumptions about this data. We'll have to take a look further down and see what's going on. So we have 3,000 rows and we have 6 columns. And so now that gives me a good idea. If this said like 12 million and 50, you would know you have a huge data set, right? You have 50 columns and 12 million rows. Like that's probably gonna like chug on your computer. Like, so that's why we do this, is like call this real quick. Oh, this is a very manageable data set. It's 3,000 rows. I know it, like 3,000 is a lot of some things, but in terms of rows of a data set, that's chump change. Even 12 million to me is not a lot, but it depends upon what you're trying to do. But it still gives us an idea of how big this data set is. Cool. Let me make sure I'm not missing anything. This thing keeps freezing. 7:32, yeah, it froze at 7:15. Okay, 1 second here. Let's go back to my iPad, please. Interesting. Okay, making sure Marvelous isn't back with us again.
How does that happen?
I have no idea.
I thought it was the link was open to. For stream, yeah.
Maybe Nate knows this guy and was just like, here you go, just check it out when you can, man. That seems like something he might do, right? I don't know, yeah. But unfortunately, my one fan is not here.
It's nice having you in class with us.
I know. Dude,
He
and
probably doesn't know what days.
I-
classes are.
yeah, that's also, I should have told him.
He probably thought
Oh, that's my bad,
He
dang.
thought it was Mondays only.
But props to him for like, I don't know, waking up at 1 a.m. and watching a class on Python. Like, that's legit.
He's still sleeping.
Maybe 48 hours later. Okay. All right, back to now. So now we have, we know what the shape of the data is, 6 column, 3,000 rows. Let's preview the data set. Remember we talked about heads, not heads, I guess. Head will give us the first typically 5 to 10 lines. That's just good enough to like again, confirm observations. Remember, I was sort of thinking that like, I thought that maybe this was like all of the doctors from 1 year was sort of the assumption that I had given the amount of rows. And then I thought there's got to be more than 3,000 doctoral graduates per year in the US. But then again, I don't know. So I need to confirm my assumptions. So here we see there's their field, life sciences, major field, another field, year. So this is going back to 2008. So this is summarized data. This is summarized by year, by field, by major field, and by broad field. And then there is N PhDs, which means that's the number of PhDs in that year for the associated fields. So now we have learned something about the data. Now I know that, again, this goes back to 2008. I should have done a tail because then I would know like when it ends, but I didn't do it. We'll do it here in a little bit when we get into the notebooks. So yeah, so I've looked at that. So this already does something for us that the next line does. This gives us the object type up top here. It says it's an object, which we know is a character, so we know that's text. Int 64, float 64. Int, again, is going to be just whole numbers, so no decimals. And 64 essentially means you can go 60, whatever 64 zeros are. That's huge. Float 64 is sort of goes the other way. That means after the decimal, we can go to the 64th, whatever that place is, sort of the other way. So yeah, floats and ints, they're just different types of numeric types, data types, basically. And so yeah, here they are. Here's data types. What we just saw up here, object, and float 64, if we call D types, which stands for data types, we can see what it is. We do have an unnamed column, which is pretty typical of CSVs. You'll probably see that when we get into projects and stuff. And then we get down, again, these are the things we just saw, int 64, float 64. We now know what the granularity of this data set is that it's sort of grouped by all of these things and year, and then it's summing the total number of PhDs for all those things. And so then we're going to check for missing values. Long story short, this data set is very clean. There are no missing values. All of these say false because they all have something there. One thing you can do with Boolean data, and Boolean data is whether it's true or false. Similarly, binary is 0 or 1. Philosophically, they are the same thing. Because you can sum Booleans too. It'll just take the sum of all the trues. The same way if you summed binary, it would just sum the ones because you sum 0 and it's nothing. Same if you sum false. So yeah, if we went through here and looked at every column and counted the number of trues, it would come up to 0 for all of them. This data set is gorgeous. And so here is a super cool thing. If you don't want to go down the documentation rabbit hole, you can use help in Jupyter Notebooks. I think you can use it in some of the other ones too. And help does exactly what it says. It just helps you. So this gives you a nice sort of demonstration of what isNull is doing. So I know we hate arrays, but here we have an array that says false, true, false, false, false. And essentially the output of this, I think it gives down here, does it? Yes. Or no, it doesn't. Oh, I scrolled down too far. Sorry. Come on. Too many scroll bars. So this is help on a function isNA. So that's, we did isNull, but this is looking at isNA. Well, it turns out isNull is just a variation off of isNA. And so let's talk about when I say isNull or isNA, what does that mean to you guys? Like can you sort of extrapolate what that could be doing? Yeah, or what is when I'm calling up here, when I'm saying I'm taking PD is null, and then I'm putting our PDF in there, what is null doing? It's checking, are there any null values in any of the rows or columns, right? That's missing data, right? And so what you read in here is that this function takes a scalar or array-like object. Sorry for the, but essentially it takes a data frame. This is a data frame, and it just goes through and it looks for NaN or none or NTA. Like, so this is NA time, I think. NaN is NaN numeric, but these are all basically null values, and null values just means that there is literally nothing there. Where there is typically a value for most of the places, there's a null value there. So again, we think back to the Titanic data from yesterday. We had one null value, which we assumed was a stowaway. So that's is NA is looking for, is it an NA? Because that's another one that can potentially be in there. All of those for everything that we're doing right now, that is just missing data. Technically, if you divide a number by 0, you'll get that NaN, but it is still treated as a null because it's an undefined value. Stop the math talk. But yeah, so we can go down here. Now we have some examples. So here it is. We're calling PD is NA, just like we called PD is null up there. And they're just putting dog in there. Is dog an NA value? No, dog is like way legit. It is not NA. It's good to go. Now, what if we just put an actual PD has its own NA because maybe you want to apply that when you're doing your manipulation. So you put PDNA is NA. Yes, it is NA, and that's what we want. Similarly, NaN divided by 0 is also going to show up as true as well. And so yeah, there are a bunch of different outputs that you then get from these things. Here's some date times. This is an NA for a date time, NAT. So if we put that in there, this one, is this NA? Nope, it's not. Is this one NA? Nope, it's not. Is this one NA? Yeah, that's our boy. And then is this one A? No, it's not. So now we can, if you're ever curious why something is doing what it's doing and you don't want to leave your notebook, you can just wrap the help around it. And again, that when I say wrap, I mean put it between the parentheses. So that's super helpful because up here, I was confused. Tim Flanders was confused because like, why is this just giving me false for everything? Like, what's really going on? So I ran the help. Now I get it. It's saying those values aren't false, like they're bad. They're saying these are not null. Like if it was null, then it would be true. And so that's super handy for cleaning data. And then duplicated, similarly, are there duplicated values? In this case, we're looking at duplicated values across all of the different rows. And it's saying false again here. And I remember I talked about how you can sum Boolean true false the same way you can sum binary just by counting all the ones. All the trues are ones. If we sum this whole thing, just add them all together, we get 0. So we're good. There's no duplicates. And our data set looks great. And then lastly, we're getting there's a function, all the metadata, again, that we talked about. When you take this CSV, you use PD, read CSV, it's going to add all that metadata. Again, the metadata is the shape that we looked at. In this case, you can also do describe, and that's going to give you mean, median, standard deviation. Typically, we have quantiles. I think the one we're all kind of most familiar with is mean, which is just the average. So yeah, if we look, the average year is 2015. So we could probably extrapolate what's 2015 minus 2008 is 7 plus 7. So 2000, this data set probably goes to 2017. If 2012 is in the middle and we know it starts at 2018, we go the other way, the same amount, probably 2017 is where the data is. We get the average number of PhDs per year is 165. That's cool. I like that. Interesting. I also see that when we count number of PhDs, this number is less than this one. So maybe I missed something. Maybe oh, I didn't scroll over. All right, so this is good. If we scroll over and we look at our is-NA, what do we notice here at the top? We got truths. There is missing data in this. I just didn't scroll over to look at that. Basically, for some years, my guess is for some years, for some fields, there were no doctors. So with that in mind, what do you guys think? And folks online too, I'm not trying not to forget about you. Feel free to chime in. What would you do with this data that is missing? We're with the assumption of we know that if it's missing for these years, that means there were none. And right now it's showing a null value. And that breaks. So you can't sum nulls in SQL. So like if I were to put this in a database, that might break things. So what's something we could do to that? We got a big tool set. We got pandas. If we could change stuff, do we want to change those null values to something else? And what do you think? I'm not trying. It's a pretty simple answer. This isn't really a trick question. If there are none from that year, then let's make it 0, right? Yeah. So that's something we could do with pandas. We could say, take all the null values from a particular column, and we make the assumption that if it's null, it's 0. And then maybe that's something that you write in the documentation someplace. And that's that. We're done. We did it.
What would be the difference between taking that field? Could you take that could you just say like it's not relevant? Or I mean, I guess it depends on the data, right?
Yes, 100%. Yep. So yeah, one thought is, so there's two things we could do there, right? We could assign zeros to those values, or since they don't exist, we could filter them out. Like if they don't exist, then is it hurting anything? But those are questions, those are business, without the sort of business mind and business knowledge of what we're working on, we can't necessarily make that call, but we now have two options though, right? In our case, there isn't a right answer, but we do know that there's at least two choices that we have, which is great. That means we're thinking about this, and we know, yeah, we got an idea of what to do.
Is that something that you would say like your day to day? Do you think that you figure this decision yourself based on the information you have? Between one or the other option?
Yes. So in the stuff that I do specifically, this is huge. In a lot of the SQL queries that I write, when they're finished, they're called models. And it's not a machine learning model. It's a database terminology thing. And so within all the documentation, we have a file that lists all of our models. And then from there, within that documentation, we can have tests that we run that essentially say check for null values. And then if there are null values, we can say remove them, turn them into zeros, or we could just send out a warning. So new data comes in, we get some null values, I have a warning set up, and then boom, I get an email or I get a message on Slack or I message on Teams saying the newest data pull from Sunglasses R Us has some NAs in it. And so I need to go investigate. Or if it's something that we know, we get NAs and we just need to filter them out, then that's what we do. So me being the person with the business knowledge about the data, I probably would make that call as a staff data engineer. Now, Tim Flanders, BI analyst, might have to again come up with those two different. We came up with two solutions here, right? We can filter all of them out, or we could turn them to zero. Both of them are going to have drawbacks, basically. So it's Tim's job to figure out what those are. And then if he can figure that out on his own and I don't need to talk to anybody upstairs, then I'm just going to do that. But if it's going to manipulate how certain visuals turn out, like then it's sort of like, okay, there's downstream effect. When I say downstream, I mean, I'm doing this one thing and other people are using it. So if I make a decision to change this thing, there's dominoes and things are either breaking or whatnot. Somebody online, I think I heard somebody's mic go off. I didn't mean to cut you off. If you have anything to say, please chime in. Oh, was that in Slack? Why am I not?
It's on the video.
Oh,
I think you can't see it unless, I thought we were Charlie.
yeah, my iPad keeps being strange. Don't know why. Technology's failing me.
Yeah.
DM, private chat. James, yeah, exactly. James, sorry, I'm getting to you 5 minutes late, but you are absolutely spot on. Your brain was exactly where, yeah. Thank you. Right, connection is lost. Yeah. Well, yeah, just want to give validation where it's needed because that's exactly what we were looking for. Cool. So this sort of illustrates something else. Make sure you scroll to the right if you're not looking at all the data. Cool. So where are we at now? We're at 7:50. We're gonna probably get back into the Titanic data set for probably 15, 20 minutes. And kind of go through some of the things that we're doing here. But again, and I'm sorry for this, I want to make this more interactive. That's why we're going to move back over to that so you guys can write lines of code. I also want to talk about like how to add cells into notebooks so you guys can like literally that all these notebooks are for you to do whatever you want with and like try things out. We're going to get to a point in the Titanic stuff where we're talking about using pandas to do manipulation on data, and you make a function out of it. And so I want to talk through what that function looks like. It's going to be great. Everyone's going to love it. Cool. So that said, I did not put the link. Can everybody go back to their Anaconda session? And I will throw a link in the chat. Do I have mine open still? No. Get out of your arc. Anaconda. Is something not working?
No, I'm not seeing the sign-in option.
You probably have to. Oh, you're on Anaconda.com class. Sorry, yeah, I'll toss the link.
Why are you not seeing the sign-in?
Yep. I'm going to put that there for y'all. Where is my... Oh, there it is. There we go. And then similarly, I'll put it in here just in case. Gonna sign in. Not gonna sign in as Ted. Hopefully, Ted, you changed your password. Also, Ted and James is I think I talked to Nate yesterday morning, I think, and he said he was heading over to Chicago to see you guys. Is he in town yet? I've put him on the spot.
I think he may be at our HIMSS conference. It's like a healthcare conference, but I didn't go. I'm just a software engineer.
Gotcha. I would assume it's boring for a software engineer. I can imagine.
I wouldn't mind, but they didn't want to send me.
Yeah, I feel you. There's a Builder Trend goes to this huge like home builder event. I'm trying to remember what it's called. Oh, let me Google it real quick because I don't want to ruin this because I think it's funny. Maybe you guys will too. We'll see. Construction. No. Okay, here's what it's called. International Builder Show, or IBS. So when I Googled this, the first thing that I put in construction, like IBS, the first thing that comes up is, oh, I thought it said irritable bowel syndrome. Anywho, that Charlie, yeah. Did he go to that? Oh, wow. See, I don't know if I would want to go to that. He said it was good or what? Oh, gotcha.
And then he was talking about how there was like competition, there was no sales, how do you know you would have, like, I don't know, because he was there, you know, certain portion of it, and it was gonna be some data visualization of like who's up running or whatever.
Oh, nice.
He didn't realize that was that thing.
Wow, nice. All right, cool. When everybody is in, we're going to start with our sample notebooks. I believe we're doing intro to data science, and I think it's pandas. Nope, it is not pandas. We're doing data analysis, number 5. This is the Titanic one we were in last time. But now, I hope we have a better mindset of what we can do with a data set like this, right? When we get this data set and we're going to do the same things that we were doing to the other one. The difference being is that you guys can run this on your computer and you can try different things. One thing that you can always go up to run and hit run all cells, and it's literally going to run the entire document. And that's totally acceptable. In fact, I almost recommend it so you can kind of see what this stuff looks like by just scrolling. But when we do want to like run things ourselves, click into the cell, and then I think it's just shift enter will run that cell. And while it's running, you'll see an asterisk next to it very, very briefly, depending upon what it's doing. And then when that asterisk goes away, there's a new number, and that's, yep. Are you having some issues?
Yeah, well, when I was at home, I just got in and I was listening to the part where I was supposed to do everything. I was just
Oh, yeah. So you're good. Go to sample notebook, that folder. There we go. Intro to data science, that third folder.
I'm scared though.
Oh.
And then we're on fire. It's all good. One thing you can do if you want to, like that little gray bar, you can kind of pull over, and then those things will be a little bit bigger. Because like when they're truncated like that, it can be hard to read them.
The sample.
Did you guys get to everything?
My computer didn't even notice.
Right now?
Yeah, it's back on.
Okay.
So I have to go back into everything.
Sure. Take it. Actually, we're at 8:00. I know we went to like, let's do another break just because we're going to get into this. Let's get into this with fresh minds. So feel free to do what you want to do. I'm going to go look at this guy.
I'm really scared because my computer is frozen on me a couple times already.
You know.
Because I closed out of it because I clicked on the wrong thing and I don't know how to get back. See, I didn't click on the properties and then the all there.
Yeah.
So you said once you click on that same goal. No problem.
Sorry, hit me again. What's that?
No, I'm like you're mentally on break, sorry.
I'm always mentally on break. Just kidding. Oh yeah. What? Now we're not going to get anything?
I think we may.
It might skirt around. So this is. Yeah. And that's, what is this? Data visualization. Woo woo. It is though, right? Cool. Okay, sorry. Sample what? Yeah, so there's a little folder right there. Like that. And then interface, third folder. Yep. And then number 5. And that's what I was telling her too. It's like you can take this little gray bar, you can move it over, and then you can just, then those things will be more easily read. Yep, and that's what we're going to do.
Well, I just have my computer lost me most of the screen, whatever, yes, screen, right?
How long have you had it?
2018. Mine's 2018 too. I would say, but the battery on this one really does need to be updated. I think it's swelling because this corner right here is.
Yeah, my buddy had one of the Macs that had the battery swelling issues, and it was like, would like wobble on his desk. And he's like, "Isn't it cool?" And I was like, "No, it's terrifying, dude. That could kill you."
Yeah, because if it explodes, it can happen. So I know, and I was like, no, it just needs to last me a little longer.
Right. I saw a GIF on Twitter a couple days ago of like a laundromat, and it just shows this guy just leaving a laundromat, and then like 2 seconds later, you see a dryer, and you see a spark. And then it explodes and it like blows out the windows. Like if that guy had been like 2 seconds later, he would have been like very hurt. But somebody just left their cell phone in the dryer, like in their pants or something like that. And the ion battery exploded like massively.
Yeah.
And it's like.
Yeah, and I think Dell is known for their battery swelling.
Yeah.
So they don't want to like really say it's their problem, but yeah, they do. They have like even specific instructions once you remove.
Yeah, I mean that's just unfortunate with technology is they kind of engineer half-lives into things because they want to sell more products, but like I don't know, batteries blowing up doesn't sound like a good reason to. Yeah.
Yeah, because I think technically the battery is supposed to, like, its life cycle is only 3 years. So I'm like, I guess technically I've been pushing it since the 30 years.
That's so dumb, though.
Yeah.
How easy is it to replace? Like, can you pop it off the bottom, or do you have to unscrew it?
I don't know.
Yeah.
To be honest, I don't know. I just know that I think I would also have to replace the fan.
Oh, interesting.
And the battery, because the fan has been making like a grinding noise.
Oh, geez.
So I think it's just a combination of.
Gotcha.
things.
Yeah.
Yeah. And I was like, if I get that replaced, I think my computer will be fine.
Mm-hmm.
It's just finding the time to get that replaced. Because I don't know how long it'll take from wherever I go.
Right.
Let me know if you have it right now. Yeah.
We'll go another 5 minutes here. I might hit. Oh yeah.
I was waiting for Nate to bring the Coke Zero.
I know, seriously.
like,
What is he coming?
I don't know.
Well, so Nate always forgets that I cycle everywhere, which is fine. But he was like, he called me on Monday. He's like, hey, can you drop by the store and pick up stuff for the room and stuff? And I was like, what was up? He's like, oh, I can't remember, he was sick or something like that. And there was something. And I was just like, I mean, maybe. I don't know if I can fit all that stuff in my bag with all the stuff I'm bringing. And he's like, what do you mean? And I was like, I'm just on my bike. He's like, oh yeah, sorry.
so how far do you cycle this year?
In a year?
No, how far do you cycle to this year?
Oh, 4.5 miles.
Oh, that's not
Yeah, and I can do it under 20 minutes, so.
bad.
Sorry, I'm not trying to brag.
No, that's good. No, you did. That's okay. When it was
Well, I honestly, when you said it was here, I was like, that's, like 4 miles is like a good cycling amount. I don't get terribly sweaty. I get bring stuff that I can do.
Oh, okay.
Like,
4 miles, okay?
What were you saying, your sister, what?
Oh, my sister and I decided to bike 10 miles. So we had moved over near Westroads.
Yeah.
And we live in South Omaha, and we're like, hey, to take our bikes over to our apartment, we'll just bike from like South Omaha to over like near Westroads. And we're like, yeah, it'll be fine. And like, we don't bike like that at home. I hadn't conditioned for anything. But we biked the 10 miles. I think it ended up being like 10 miles.
Yeah.
You're going up and down, right?
It was, I don't know, it was all of the.
Is there a trail that connects that? Did you guys do any trail riding?
Yeah, we took, I don't know what's that trail. It's that trail that goes, I just know it goes by like 42nd and like Epish. And then I think it's the Papio Trail. Somehow
Yes.
it connects to Papio
Yeah.
Trail. And then we took it all the way to like near
Are you
West.
going around?
Yeah, the trails are unfortunate. Like, for me, if I wanted to take the trails to get to Builder Trends, I'd go like 15 miles, like down into Bellevue, and then on the patio, like all the way around, which like, I wouldn't have to deal with motorists or anything, so like, you're pretty.
I did like park a car, a big like park, hit that trail to hit, like, I'm basically going behind the, there's a trail going towards the pedestrian bridge.
So you cycle everywhere when the weather permits, right?
I mean, I was gonna cycle home even though it was gonna be raining. Like,
Really?
yeah, I got my rain jacket back there just in case.
Okay, but the snow.
No, I love riding in snow, actually. I prefer to ride when it's cold because I get so hot. Like, I am just constantly.
Do you like change your tires or anything for this?
I should, but I didn't. I know, like, most of my friends, like you were saying, your husband has like a fat bike for the winter. I should invest in one of those, but again, I work remotely, so most of the time, like.
He only bikes the red car, it's like a mile.
Oh, really?
He's like sometimes just buy 2 bikes. He does it every day.
That's fair. That's
He
fair.
gets to and from, like, say he has an hour lunch, so he'll bike back home and eat and then back.
Okay.
Like, he does do like maybe 25 minutes of biking.
Yeah.
So, like, I can't justify that. I mean, I wish I could.
Yeah.
But no.
Yeah.
And he can like live up a hill,
Oh,
and like he can go up a hill and down a hill without a problem. And I'm over here like just struggling to walk. So that's why I'm like, why can't you? But he like does that like slow and steady and goes up to the. I'm
Yeah.
like, I don't know how I'm doing this. He's just-
I used to bike everywhere when I was younger.
oh, back in the day. He didn't have wheels.
No, I don't know. But I shoot up things like it was nothing. I stand up, you get something.
Oh, yeah.
In the middle part, you have to stand up.
Yeah.
It's just he gets punked a lot by like, cause now all the bike lanes are now with the drive, like the cars.
Some of them,
And
yeah.
Some of them don't, like, it's the same lane.
Mm-hmm. Share rows.
He gets, cursed at, figure on, like everything.
What street is he riding
We
on?
live in Iowa, so Casablanca.
Oh,
So we live by the new YMCA.
gotcha.
We work at the library.
Okay.
So it's that Casablanca library.
So he takes the main drag, basically.
He has to, because there's no.
Yeah.
He's figured out a way to go like behind like the main streets to go.
Yeah.
Alleys and stuff.
Yeah, yeah.
Guys don't like going to the alleys
one, because, the bikes are gonna be more like frequent to repair them, because there's not glass.
It's not nearly as,
Yeah, and second, it's really more than one. That's just me, like,
yeah,
so, I mean, at least you would be home, but yet you wouldn't get, you know.
right. That's a bummer. And Iowa's supposed to be like one of the most bike friendly states because they do ragbri and stuff. And like, I don't know. Probably, yeah. I definitely go out of my way to not be on streets that are like that.
And you have to with where we're at.
I know. And when you do, you do. Like, I know how that goes too.
He's pretty good about it.
Yeah.
And he wears like the whole like neon color. I look like, oh, you look like those people that cross.
I got out of that phase like 2 years after like cycling full time. I was like, I feel like an idiot. Like, oh yeah, I mean,
Oh my goodness.
Like Eagle's hat. That's what he has his hat. Let me find it. And his hat is neon green. Like, so think of that. He does not look like this guy. See his hat? That's what he wears. He wears this kind of hat, but it's neon green, like neon or ornaments. That shirt. That's what. And that's what he wears. And then, yeah, like take that hat. I love it. So if it were his name, there would be.
Yeah.
I have that thing. And he has he's so in certain like reflecting things.
Yeah, yeah.
Yeah.
You're doing that on purpose. Yeah.
He does.
On his jacket? Okay. Yeah, I mean, I have a light on my bike. Oh, okay. Okay. That's, yeah. Dig it. What do you, it better not roll in. Well, yeah. The winds better not have shifted because I'll have a tailwind going home because I had a headwind coming here, which sucked. So I was like, oh, when I go home, I'll have a tailwind. I'll go super fast, except the storm's rolling in, so it's probably going to reverse. So whatever. Cool. All right, let's get back to this stuff. So we just did some again, I called it initial EDA. That's initial exploratory analysis, data analysis on our PhD data. I had some assumptions that were wrong. I thought that it was all PhDs from 1 year, when in reality, after we looked at the data, we saw that it was 2008 to probably 2017. I thought that there were no nulls, but then we saw that there were in fact nulls. Business logic sort of, this guy's about to open up this door. Don't do it. Okay, he opened up that door. I thought he was gonna do ours too. Anyway, we saw that we were missing data in that one. Business logic that I just kind of made up determined that that was just because those fields in those years didn't have any. We came up with some potential solutions. We can fill it with 0, or we can exclude it, as James said. Make sure everything's working here. Man, this thing keeps dying on me. Okay, whatever. Do this real quick. Back to the iPad. There we go. And I'm calling Apple. This is not working right. What? Sorry, gang. There we go. So now all of that stuff that we did, we're going to kind of do the same thing with the Titanic data. A lot of this is already coded in here. So are you having some issues, Rochelle? Where's special notes?
You had it down here.
Down here?
Maybe it's a drop down you click on.
Special.
Okay, I mean, I'm looking at it right now.
Okay.
Analysis.
Okay. Yeah. And again, actually, I'm going to restart this and we're going to go line by line because I think that's fun. So that's something, here's something else you can do. Again, I recommended that if you go to run and run all cells, it's going to run every line in the document. It's going to pre-do it. But it is kind of fun to run it line by line to actually see what's going on. So if we want to do that, let's say you've already done run all cells. And if you have, that's totally great. I told you to do it. If we go over to kernel, if we restart kernel and clear all output, we're going to click that and it's going to be like, are you sure? Yes, let's go. There we go. Now everything's gone. We have a document, brand new. Yeah, so I'm going to run this line by line. Again, we do shift enter to run the line. This one is giving us the Titanic text description. Again, this is a text document that is on here. We went through all this stuff and kind of talked about it. I guess I didn't read the story behind the data. That's interesting. Was that what it was? Got it. He's back. Throw my copy at him. All right. Okay. So this is funny to me. I don't know if you guys will find it funny. An interesting result may obtained by using the HMISC functions in S+. S+ is like a prototype to the R language. I don't think anyone has used in a good hot decade. So that sort of dates this data as far as like how old it is. I think it says the original HTML is from 1999. So yeah. Yeah, there's interesting stuff in here for sure. Bet if we go through this, we could probably figure out who the stowaway was, maybe. But anywho, we'll keep rolling. So now we're going to load in the data. So again, I'm going to hit Shift. I'm going to enter, like, just kind of go through these lines. So the data is in there. Hit it again. We have, and again, I talked about, we don't need to know exactly how this is working, but essentially this OS is finding a path through the file structure on here, and it's saying this is where, actually, and if we take this, and let's see here, this is different than, nope, go away. So if you hit this little plus button right here, it'll make a new cell for you. I know that there's a key command for it, and I can't think of what it is. There we go. Insert cell below B. So exit B, 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 B. Okay, so that's how we do that. So we've defined this Titanic data set right here as this is the path for, like, in my documents folder, go into the data folder, and then there's a text document called Titanic. So that's essentially all this is. So if we run this, that's what it looks like. So again, this is on our virtual machine. This is not on like your actual documents within your document. So this is the home folder into this big long jarbled folder into sample notebooks, which now we're seeing stuff that we're familiar with, right? So this is going into sample notebooks, intro to data science. It's going into data. It's going into Titanic. And look, this is literally what it's doing. It's just going into this folder and it's reading the CSV. So then we're going to do enter a few more times, shift enter. We got our tail. We got our head. Remember, this is all stuff we were just doing. Column values. This is just the names of the columns. Remember, describe. This is, we were doing this. This is when we also last class period when we determined that we were missing some data. Again, somebody didn't pay for their fare, so we think it's a stowaway, or at least we like to think so. Then similarly, we look at data types. This is all stuff we've just been doing. So now we're going to get into some of the is-null stuff. Again, we can use the help document, the help thing if we need to look at this to get a better understanding of what we're trying to accomplish with these functions. So we're going to run is-null on the body column. And so if we recall, the total count of rows in this are 1,309. If we look at the count for body, we see that there's only 121. Which means there's lots of nulls. So let's run this. Look at that. So the first 3 are nulls. And then similarly, there's some more going down. So let's see how many are not null. So that's, intuition would say, if there is a function that is null, saying, is this null? Is there another function called not null? Is this not null? So it's just doing the opposite, right? So if we run the same thing, we can see it's literally just the reverse of that. And then, so this, now we are taking all of these, let's say we want to sum what all that looks like. There's multiple ways to do this. So in this case, they are assigning the values to a values thing. And if we want to, what does that look like? Like we don't actually see what it looks like. So if I hit it, oh, okay, so it's an array of true, true, false. And so then when we sum those together, this is how many NAs we have in the body one, or in the body column. But let's see if we can do, let's try and do that on our, without doing the values. Let's see what happens. Put that in there and run it. Look, it's the same thing. So this essentially illustrates, Charity, I think you said it last time, that there is no one right answer to do things. Because what do we do here? We have a method for calculating the total sum of values. In this case, we pulled the values out of this. I don't like this method. Personally, I think that this is confusing to me. Like dot is null, dot values, dot sum. It's like, no, I know that I can just sum all the truths. Like this to me makes more sense. So let's pause there. I'm kind of going through this fast. Is everybody being able to keep up in terms of like running the code? Is anything not making sense? Do you want me to revisit anything? Folks online too, obviously. Cool. What's that?
When I run it.
Yeah. Folks online, the issue that we're having is when some people are running columns, they're turning red. If anybody else is having that issue, definitely holler. I'm going to kind of troubleshoot with them for a minute. Okay, so this is a very, very good point that I'm glad that this is happening. So when we run code, it's run incrementally.
Okay.
So every time, yeah, so you gotta load the top one and then load the next one. So run that one. So shift enter, and then it should put you into the next one. Yep, and now you shift enter for that one. Now what you've just done is you just defined data. So what this error is saying, data is not defined because you didn't run the command before. You had to run the command. Yes. So you can see that's kind of what the numbers look in, because you can see what was the last thing I run. Was this run?
So what are the
That's just telling you.
Because it doesn't start from one.
Right. So at some point you ran some other stuff.
Oh, I see.
Yeah.
Yeah,
and yep. And so the same thing there. Yeah.
okay, got it.
So that's why. Yeah. Listen.
So,
That'll do it. Yeah. Yeah, so when I made like my own cell, yeah, that's right. Yep,
Okay.
for sure, yes, and feel free to like try some stuff out yourself, yeah, I mean, I'm not, feel free not to do that. Like,
I was just watching, not be doing eventually down.
I got you, yeah. And again, if you want to run everything at once, you can run all cells. Okay, is that what we're doing now?
Yeah,
Yeah.
I think I run it first, and then I wanted to do how you did it.
Yeah, so let's, I'm gonna recreate, yeah, of course.
So my number
Yeah,
14.
that's why I do like typing out.
So those numbers are gonna be different on everyone's computer.
Oh.
So that just means the order that you ran it in. So that's just telling me essentially this line was the 14th thing that you ran in this document. This was the 16th, this was the 17th. Every time you rerun it, it's gonna do another iteration. So like literally, if I just run the same one, that thing's just gonna count up. So it's 17, now it's 18, now it's 19, now it's 20. Now, so what this does, and this is how we were able to diagnose what was going on with Brenda's, is that the one that actually defined, the cell that defined the data itself, which is this one, because we're importing another library, then we're defining the path, the folder path where the CSV is, then we're actually bringing that CSV in as a data frame called data. So because that didn't occur, data doesn't exist. So I'm literally going to recreate this so we can kind of see what that looks like. So I'm going to restart kernel, clear all output. And so yeah, we're going to hit doot, pandas. So I just ran pandas. I'm going to skip this and I'm going to hit data tail and it's going to say, nope, what's going on? So error messaging in just about any language can like be not very helpful. So you kind of got to decode it because again, a bunch of programmers put this together and we all know how easy it is to talk to like a computer program. Just kidding, James, you're great. No. If you're not used to seeing this stuff, it can be daunting at first. But essentially, this is saying it's pointing and it's highlighting at data, saying name data is not defined. That's a weird way of saying there's no data, like there's no object in here called data. So it's literally just because I didn't run this command. Oh, data.head's right there. Yeah. Yep. So because I didn't run this cell, data doesn't exist yet. So now I'm going to run this cell and then I'll run tail. Boom. Now it's working because it knows where data is. Boom. Now it's working. We're good to go. Yeah. So again, that's why sometimes what I like to do if I'm making a change to a cell and I want to make sure that everything, like the lineage of my folder, like everything has run incrementally so I don't run into these issues. What you can do is you can put your cursor on a column and you can say run all the above cells. So this is literally going to go do all that stuff. So now, and you can literally see it. You can see 7, 8, 9, 10, 11, 12. And then we got here. Now I know everything above this has been run, so I know data has been defined. I can see the output from these other ones. We can just roll through that. Cool. So let's get into this stuff. So we saw, I'm going to do the same thing here where I'm going to go run all above. And scroll. All right, so the last thing we saw was that there's multiple ways to do things. That can be said with just about any programming language. Doing the thing that makes the most sense to you, but that is still readable to you as well is very important. One thing that happened to me quite a bit when I was first getting into coding is I would like and you guys will likely experience this too when you get into some of the project stuff, is that some things will start to click and you'll get in the zone and you'll be like, oh my God, I'm coding. And it's really cool. But if you lose that headspace because you don't do it all the time, you might come back to it and be like, what was I even doing? Like, just because this is new, that's okay. That happens. So if your stuff is legible, in this case, this is more legible to me than doing things like this. That could help. Another thing to think about, within these docs, you can write stuff. So for instance, we keep seeing all this stuff that's in here. If we double click this is a markdown frame. So I can write more stuff in here if I want. Yo, check it out. And then let's do some bolded stuff. Bold. We did to that, and then hit Shift Enter, and now that's in there too. So if you want to write comments like that in these documents, that's what that is for. And then I believe if we do like a right click. Yeah, so if this is specifically called a markdown cell. So markdown cells are for documenting. Python code cells are for code. And I just want to make sure everyone can kind of see where this is. When I click this, if we look up here, this says markdown. And then if I click into this code cell, if I look up here, this says code. So if I want to, I don't know why I would, but if I wanted to, I could change this to markdown. This is no longer Python code. This is now markdown, right? Basically. Markdown is like a old school way of, yeah, if you can see like this is what markdown code looks like. It kind of looks regular, but we can see that like you do double stars to do bold. If you do the ticks, you can make it look like super cool code function. And then I do that. And then now it looks like super cool code, right? Yeah. So that's, there's some markdown cheat sheets. That's here nor there. You guys don't really need to know how to do that. But just when you're in these documents and you mess something up and it's like, how is this not even code? This is supposed to be a coding document. Well, it can be code. It can be markdown. And I actually am not terribly familiar with why people use raw. I'm a coder markdown guy, I guess. I don't know. Let's just throw something into raw and see what it looks like. Raw. There we go. So it's nothing. So it's literally, it's like a mixture of markdown and the code chunk. It still looks like code, but it does not execute, but it doesn't look as pretty as markdown.
I guess my question is, we made some changes on the markdown.
Mm-hmm.
It won't save unless we save it, and it does save. Because I see that the floppy disk image on,
Mm-hmm.
So if we save it, does it save on our
Virtual environment. Yep. But that's a good question, and I will be developing like some actual notebooks that I'll be giving to you guys. And to do that, we're going to go to File. I believe there's an import. Or no, it's this button right here. So when I do have some notebooks, we're going to hit that button. We're going to go to it on our computers and upload it. Similarly, if we want to download it, oh, that's new folder. Can I undo that, please? I'll just delete it. I guess it doesn't matter. Let's say I want this Titanic CSV. I can hit download right here. Boom. Let's open it up in not Excel because Mac uses numbers, I think. I didn't even do it. Yeah. Okay. Man, my extra screen keeps freezing. Disconnect real quick. Technology's great till it doesn't work. Yep. Oh, there it did. So, yep. Making sure I'm not missing any DMs, I guess. Okay, so good. All these are really good questions, by the way. So now we are going to get rid of some null values. Pardon me. So we're going to use drop NA. So let's see. Let me run this real quick. So not null. Let me get a code chunk here. And if you guys want to do this too, again, if you're, and then here's just some little cool, just shortcut knowledge. So I am in a code chunk right now. And how do we know that I'm in it? We can see my cursor is blinking, right? And so I can type and it's there. If I hit exit, I am now outside of the code chunk. But you can see the little blue highlighty thing next to it. That means I'm still centered like on that one. So if I hit run all above, it's still considering me on that cell. So it's run everything above until that cell. Now, why is that cool? Because if you hit exit, but you still have that one going, you can hit B to get more code chunks if you need to. So this is really handy when you want to iterate through stuff. So for instance, maybe I want to do data head, and I want to look at 100, and I'll hit that enter. Again, I am now outside of the cell. I'm on this one. I'm going to hit B, and I've got another one. Actually, how do I do one above? Above, below. Oh, that's what it is. Yeah, these guys. And I think if you hover, yeah, I'm an idiot. A is above, B is below, because A and B. Yes, so A, B. All right, so if we do have an empty cell, I mean, let's go ahead and make one and just type in data, because again, that's our data frame, that's Titanic data, and then hit dot, and then I think you hit tab. Cool. These are all of the functions that are sort of like when we read the CSV in with pandas, and I talked about some of the metadata and stuff that it added. It also has these functions that it pulled in from NumPy, the stuff that we looked at last time. So we can look at aggregate and all these different things. We're not going to mess with this too much. But here's some of the things we've been using. Here's dtypes. Remember, we use dtypes to look at stuff. What else we got? Ooh. And so this is also cool because now we can see what these things actually are. So we have functions, but we also have an instance. What's an instance? Well, age, wait a minute, that's one of the columns. I can call that and run it. Oh, there we go. Now I have the age column right there. So it's really that little dot and tab and just going down all this stuff to see what's there is cool to explore, to understand the sort of capabilities that this data frame has. There's plot. We're going to do some plotting later. We can rename stuff. Yeah. There's our tail that we've been using a lot. Yeah, so all these should be, some of them should be familiar, and they're all in there. And describe is in there, if I can spell it right. Yeah, and then, so that's just a good thing to know. Yeah, so drop NA is one of those things. And so we're going to do, the drop NA function does not modify the original data frame. It returns a new data frame instead. So what is that? Let's think about like sort of what that means. That means that we sort of have lineage, right? Like, do we want to irreparably get rid of stuff from our data set, like, and just have a new one? It's like, well, no, there might be stuff we need in there at some point. So when we do this, this is a new data set that has dropped all the NAs. I don't know. I don't think it did it. It's not, but it returns a new data frame. Gotcha. So because we did this here, we said essentially all of them rather than any. So it's only going to drop things when we set it to all. It's only going to drop rows where every single one of them is NA. And that's handy, right? Because if you have an entire row of NA, there's probably no reason to have it. But what if we want to just get rid of every single column that has an NA in it? So let's get our assumption. So if we're getting rid of every single row that has NA in it, remember our body column only actually had 122 rows, right? So we're likely only going to have 121 come out of that, but we also had the one NA in the ticket fare too. So we're going to have 120 or 121 when we run it again. So here we're saying place to drop NA. Moreover, we can change the axis on where we would like to perform the operation.
What is the how HLW stand for?
That's how do we want to drop them? So that's sort of what I was saying, how all means it's looking through every row or axis. In this case, I think 0. Let's do this again. Let's do. Mm-hmm.
Yeah, I have looked at.
Nice. So yeah, that came up with 0. So then we do this one. Let's do drop NA shape. And let's check our, oh, I didn't do it. Oh, in place? I might have to. Well, oh, it doesn't even have anything. It must be interesting. Oh, here it is. There's also boat has NAs too. I missed that. So basically, so let's go back through and look at our describe. And let's see if we can get to the bottom of this. Is it here anywhere? Here it is. So when we do describe, we only get our numeric things because it wants to give us these nice little things, but you can't have an average of words, right? So it looks like we're seeing more NAs in boat as well. And I don't know why boat looks like a number to me. I wonder why it's not showing up here. P-class survived. Okay, here we go again. What do we notice here with boat? It looks like a number, but it does not talk like a number. So we were seeing a number here, but when we look at D-type, we are seeing that it is an object, so it's not a number. Does that make sense to you guys? Like why? So this is illustrating why we have to do data cleansing and data cleaning, right? Float means it's a decimal number. And then int means it's not a decimal number. It's just like a 10, 20, like a nice even, yeah. Yep. So yeah, floating point is what that's a reference to, which is programming, I think. I don't know if it's technically a math term. So let's see if we can. Let's do is NA. Let's do boat. Is NA Oh, it's ha. Is it funny? Nope. Is it NaN? Nope. What's our data boat look like? Am I crazy here? Was that not called boat? Or is it called boats? Right. I'm just curious here. So again, this is why sometimes it's good to restart and run all cells above.
Around, when we had talked about the get rid of no values, the data drop NA axis.
Yeah.
They have both and they have numbers with NaN. Is that supposed to be? So when you run when you're running this here, well, it has two numbers for 0 and 1, but then all the others are NaN. Is that normal even though it's an object type? I guess that's my question. These two are numbers. But
That's exactly what we're talking about.
Yeah.
That's weird, right? Yeah. So this is why we have to do data cleaning. So we would definitely want to turn that into a numeric object. But what I can't figure out is why mine doesn't say it exists. But yeah, you're 100% spot on. That is weird. It should say NA and it says NaN.
what is scalar? SCALAR.
Scalar?
Yeah.
A scalar value is typically a number. It is typically like, are you reading that in the documentation?
Yeah.
Yeah.
Parameters, OBJ, scalar or array object to check for no mismatch.
Yep. A scalar is just a number. It's another word for number. Yep. Okay, let's see if I can find boat. This is bizarre. There it is. Hooray. Okay, I don't know. Again, that's why when things aren't working the way you want to, rerun everything above it, and then you'll have like a fresh set of data to start running. So we're going to say sum is NA around this. Whoop. Oh, whoops. I'm writing in a different syntax. That's bad. df dot, oh wait, and it's PD is NA 823. Comparing that to, what was the other one? Body? 11, yeah. So what's going on here is that pretty much from what we can see here, if there is a boat value, there's not a body value, and vice versa. If there's a body value, there's not a boat value. This probably has to do with the type of data that is. If we go up here, look at the documentation again, I'm sure we could figure that out. But essentially, what the drop NA is doing, in this case, why it's returning empty, is that in every single row, there is at least one NA. And since we said omit any row with any NA, it's just like, all right, there's nothing, because there's at least one NA in every single one. Does that make sense?
Yeah, I gotta figure out why we both, if it's both, then it's A and I, and why there's nothing for body, because there was someone in the lifeboat.
That's what I was.
Dead body. That's what it is.
That's what I was just thinking. Yep.
The dead body. Instead of time, so they were in the lifeboat. Yeah, the movie. Yeah, the.
Right.
DiCaprio.
There was room on the door. There was enough room.
Everything after that was like, oh, yeah, well, that's the theory.
Yeah. Mm-hmm.
I would love to live in my heart to see it.
I would like to think about banana bread, but it was cool, okay.
So hopefully some of this is starting to click a little bit. We're getting close to time. We've got some NAs. So let's say we're going to go down to the filling the NAs. Filling NAs is very simple. You use fill NA. I mean, again, we couldn't be more sort of on the point with the names of these functions. Is it NA? Is NA. Not NA? Not NA. Fill NA? Cool, let's do it. So in this case, you literally just put whatever you want to fill the NA with. In this case, we're just straight off the data. We're using the data object. We're saying fill NA, fill it with 0. We're going to run that. Look at the head. Boom. Look at that. Body, 0. Boat, 0. So this is what I was talking about earlier. This is a potential solution for the PhD data that we were looking at. We had NAs in that. This was the first solution that I came up with about entering it with 0. If we wanted to use the solution that James brought up, we would exclude it. We would look at that column, or we would say any column is NA, and you would filter it out. So that's how we could achieve both things. Here, we're filling these with 0, but we can also do unknown. So this, to me, gets problematic because unknown is an object, right? It's not a number. So if we have NA values in numeric columns, does that, I believe it changes everything. Yeah, so we have age that is filled with unknown now. That's all unknown. So was age in our distribution or in our describe? Age is. So age was originally a numeric value. Let's run that describe again and see what it is now. So it's now unknown. So we're going to go above. So we have data fill label dot describe. Can I spell? The answer is maybe. There we go. Ooh, so when we're filling NAs with a different type of data type, it's going to convert that whole thing into whatever data type the unknown is. Does that make sense? Yes. So initially with the original, here, I can actually do both of them side by side. Or yeah. So here's our original data. Remember, because we're never overwriting our data when we do these things because we want to do this exact thing. So original data set, these are all our numeric values, right? So here's age. We can see the average age was 30. The median age was 28. That's interesting. There was an 80-year-old person on that ship. Anywho, now we saw, let's see here, if we look at the count on age, we can see that it's less than 1,309. So right away, just noticing that there's a difference, we know there's an NA. What's up? Yep. Mm-hmm.
And the number next to that it says 135.
I didn't read the documentation enough on that data, yeah.
I was just looking, I found it interesting. I just told Alice and them the only one that made it with the baby.
Holy moly. So this was 1912, right? So that baby is still alive. That baby's like 110. Yikes. Can you imagine? I mean, I don't want to. Now that I have a child, that stuff hits. It's hard. Yeah, it's.
I mean,
Right. Yeah. Gotcha. So back to what was going on. We know we can see that there's missing data from age. We can see here that age was a numeric data type. So when we fill it with an object with a not numeric data type and we do describe, it's gone. It is now converted to a character. So it is no longer a numeric type. So if I wanted to try and add that column with another numeric column, it's not going to work. So let's replace it with 0. Does anybody want to take a guess? Do you think is it going to keep it numeric? Is it going to? Now we do describe again, and age is back. It is full because we've replaced all the NAs with 0s. In this case, if we're trying to do age analysis, I don't think that we can confidently assume that if the age is NA, that it would be 0. In this case, I personally would default to filtering it out if I'm trying to do an analysis on age.
Can you go back up?
Of course. Which one?
Well, because you said that when you run the other one, because you took out the NAs, so it's the fill, was it, I guess, what did you put on it to take away the NAs?
For the age one?
The one on the bottom, I guess, like that.
So yeah, so initially when I filled the NAs with a string.
Right.
So age is still there. It's just when it's NA now, it's not a number. It's a string. And so it also took all those numbers and converted those to string. Right. Well, I say string, Python says object, but string, text, all of that stuff. And so it is no longer, you can no longer run numeric operations on it, like mean or standard deviation or anything like that, because it's converted it to a string because we've filled the NAs with an actual word rather than a number.
Thank you.
Yeah, of course. So you can see that Tim Flanders has a lot to deal with this Titanic data set, because it is where, as the more we get into this, you can see that there's stuff that doesn't make sense. There's missing data. There's a lot of research that we have to do to understand what the data is. We have the documentation. I obviously didn't read the instructions because I'm a man and I don't do that. But like you guys did, you guys were like, oh, it makes sense. Now that I have the business logic for this, it makes sense that these two things would be mutually exclusive because you either died or you got on a lifeboat. So suddenly it makes sense why everything gets filtered out. So that's illustrating exploratory data analysis. That's 100% exactly what we're doing right now. So if somebody, wherever you are, or end up in a professional setting and you're doing work like this, these are the things to look out for. Hopefully it's not, as like depressing as this data. Right. Yep. Right. And they didn't get down there until 70 years later. And I can't imagine, it's amazing. Is it bodies found, like recovered afterwards? Yeah. Okay. That makes more sense, because once they get into the water after 70 years, you got to just deteriorate or something, I guess.
One of the doctors in this, it's going to be better, but most of the kids weren't usually with their parents. They were with like a sibling or like nanny or like someone who's not parents, and they're usually going to see the parents or something like that. Or like, so a lot of them, they weren't even with the family members when they passed away. It shows different cases and like,
oh, I'll pick a new data set. Sorry about bumming everybody out so much.
18, get married to a 32-year-old man. Drama there.
Reality TV, Titanic. Sheesh.
Yeah, this is very depressing.
Yeah, sorry. I'll pick it.
It's interesting because it's historical.
Right. And you guys are literally, by digging into this data, this is what you would do at your job when you were doing BI stuff, is getting into the data and understanding it and being able to speak to it.
So when you're looking at the descriptive abstract, do you typically do that, like at your day-to-day job? Or do you feel like it's already, the summary of the data is already provided to you and gives you some content?
So it depends. So one of the things, So what we're talking about here with this data is sort of like somebody gives you an Excel document and you're doing analysis on it and you're trying to make sense of it. But when you guys did SQL, you were probably connecting to databases and stuff like that and getting that stuff out. So another thing is sometimes businesses use software to like track sales, like Salesforce, if anybody's ever heard of that. That has an API that will sync all of your data into your data warehouse. And so that's the type of stuff that I have to do, where I have to go through all of the data documentation that Salesforce has and make sense of it from that point of view. So it's like this, but to like, again, just scaled up. It's like they stopped using Excel docs and now they're using software. But I still need to get in there and look at the data just like we're doing right now. Do the same thing, check my assumptions. Like maybe the time zone is off from what we're used to using. Maybe we're looking at pennies again. And I bring that up because I had to do that just the other week. And I was like, who would ever do that? Or sometimes we look with the app that we have, we look at the amount of time that a user spent on a certain screen. That's in milliseconds for some reason, which like just spending a millisecond on a screen, just a millisecond has to take like, you have to be really fast to get in there and get out. Like, so like, why do we need that level? I don't know. So, but anywho, I think somebody's timer just went off, meaning it's time to go. Gotcha. Yeah, so we will end there today. I promise I will pick not such a bummer data set next time. But we're gonna kind of continue on. Let me go back to the sort of overview, just to sort of set expectations for next time. Where did my deep note go? It's gone. I've deleted it. Sign in again? Cool. So we did initial EDA. I think we got through that. And we discovered things about the data that, isn't great. And so next time we'll get into data. We kind of touched on data cleaning as far as like us filling NAs and stuff like that. But next time we're going to get into converting types. So for instance, that boat type was a string for some reason, but like that's not useful to us as a string. So let's convert that to something that's numeric, and let's figure out if we can get some information out of that. And yeah, we're just going to continue down that path of taking this data and getting it into a usable spot. Again, I probably will pick a different data set. Unless you guys are liking the Titanic one. It's fine. Okay. You can tell who's really like getting super granular with the data, and then you guys are like just running the code like, yeah, no, it makes sense. I get what's going on. It's like, but they have like the names in there too. Like it gets pretty personal. Yeah. Yeah, cool. Well, we will end there. Folks online, everybody, you guys good to go? Any questions, comments, concerns?
Good to go. Thank you.
Awesome.
You know what S plus means, right? I don't know what it means.
So that's what I was talking about earlier. Okay, I'm going to end here. S plus is an old statistical language. No, that's linear algebra is also old statistical language that you do by hand. No, that's all good. S plus is